Good morning, everybody. Okay. And we are waiting for a few people to show up. Hi, Dimitri. I'm saying I have a unstable connection. I'm waiting for that to clear up. And Dimitri, did you have a chance to try to do that worksheet that is in Google Classroom? Yes, no, maybe. I don't know. I don't remember. I have not. Where am I? Which one? The one on chemical and physical changes in matter. That's the one. Hey, David. Glad to see you. Hopefully we'll get Mr. Fosnight on in a minute. And I did post an assignment. We talked about a lot of this stuff on Friday, so I'm expecting that this session is going to be kind of short. Not Friday, on Thursday. And of course, I can't find the stuff I was looking at. Oh, here. I believe it. I don't remember when I posted that, if it was yesterday or a few days ago. I've been having trouble. I've learned how to split documents now, which is really cool. Where you have multiple pages and you can split them up and only assign one page instead of 4 or 20 or whatever. Mr. Fosnight, where do you have Pong? So, it's important to understand the difference. I did have a message this morning saying that I don't understand the assignment. Basically, the assignment has questions about chemical and physical changes. For example, there's a question, which of the following is not an example of a physical change? And they're listed. So the other day we talked about, I just went through some examples, which is what I'm going to do again, just a kind of reminder. Maybe somebody can remind me, what is an example of a physical change or chemical change, and how do we know whether a physical or chemical change has occurred? You know, what kind of cracks me up is since yesterday, all my papers are just displaced, but I've been sharing this space with my daughter. She's got her desk set up behind me, and so we've been kind of shuffling things around. Nobody's answering. So remember, physical changes, chemical changes, there is a difference. between physical and chemical changes. And one example that we talked about in chemical change is if something gives off light, if light is produced. Most of us have used those little necklaces that you get that you can use during the summer, during the holidays, during Halloween, during 4th of July, where you have it in a tube and you break the tube and it starts to light up. That's a really good example of a chemical change. A chemical change is taking place because it is producing light. So one example is that light is given off. Anybody can think of anything else that we talked about? The one that we don't usually fool with in a lab would be change of taste. But remember, think about your senses, because most of the time chemical changes, we're talking about what can we observe. In 6th grade, we spend a whole day where we are talking about using our senses for science. Okay, so popsicles, are popsicles a physical change or a chemical change, Dimitri? Because that is a good example. And I ate a popsicle on Thursday, if I remember correctly, as a result of that, because it started to melt. Is popsicles a physical change or a chemical change? Okay, you said chemical. Okay, so let me ask you this: it's a popsicle is basically H2O. Yeah, H2O plus H2O plus glucose or sugar. Okay. So when we freeze it, what is the new chemical formula? Since you say it is chemical, artificial flavoring. If you're saying it's a chemical change, what's the new formula once we freeze it? Yeah, it's nothing but flavored water, right? It's just water with sugar in it, basically, and a little bit of flavoring. For the most part, it's H2O and glucose. That's probably 98% of what it is, are those two ingredients. But Dimitri, I'm going to pester you on this. You said it's a chemical change. What's the new chemical that's formed? Remember, when a chemical change has taken place, we have a product. We have a new chemical that is produced. So what is the chemical formula for ice? Do 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 do. Maybe I need to give that to you. Oh, so when you start to think about it, right, you realize that, it's not a chemical change, it's a physical change. What's actually happening is it's still H2O and glucose, it's just frozen H2O and glucose. Right, nothing changes, we're not producing something new. That's important for us to sit and go through and think about. And I wasn't trying to pick on you, but I was trying to go through that process so that you could go, oh, yeah, it's not a chemical change. I didn't produce anything new. I just changed the state. I took that H2O and I froze it. So nothing changes chemically. The only thing that has changed is its state. It's gone from a liquid to a solid. We talk about the main three phases of matter: solid, liquid, gas. And good morning. And so this is why we spend time reviewing, because sometimes we still struggle to remember the difference. And so I had said that one of the ways that we know a chemical change is taking place is because it gives off light. There's chemicals that we can mix together that will explode or that will burn. When something burns, we see light. What else do we sense? What else is given off if something ignites? The other thing I'm going to do is I'm going to hold up this old railroad spike. This doesn't look anything like it looks when it's brand new. So what has happened to it, and is it a physical change or a chemical change? Yep, you also smell the smoke, right? And so carbon is released when something is burning. And so anytime you have, sometimes you can have light that's given off without producing smoke, like those wristbands that you get at the dollar store that light up at night. And so this, when we're talking about this metal here, that's called oxidation. That's right. And that's where oxygen is interacting with the iron and oxidizing or producing what we commonly refer to as rust. And it kind of looks like one of my ducks. All right, so that's a chemical change. Sometimes we can smell when there's a chemical change. Last night was garbage night for me. And I was making sure the can was as full as I could make it. And boy did the garbage smell. Yeah, everybody's eating at home every meal now, right? We're all at home. We're all eating a lot more. We got more garbage. Something in that garbage was actually going through a chemical change where it was starting to rot. And so that change in smell was really obvious. We went in there and it was like, man, oh man, yeah, there's a chemical change going on there. So a change in smell, light given off. The other big thing is, and this would be included in a if you're lighting something on fire, but not always. Sometimes a gas is released. Was it a banana? Now, rotten bananas go in the garden or the compost pile, or Mr. Fossley's got me making banana juice. He's been a big influence on me. And so sometimes a gas is produced. I know when we take, where's my beaker? All right, doesn't matter. But if we take and mix vinegar with baking soda, what happens? It fizzes. What it's actually doing is it's producing a gas. Those bubbles are being released, okay? And so that's an example of a gas being produced. Gas, change in smell, sometimes a change in taste. That's something we don't normally do with an experiment, but a change in taste can occur too. And I remember when I was in college a long time ago, learning about how they discovered, I think it was NutraSweet, um, the artificial, or maybe it was saccharin or sucrose, the artificial sweetener. It was by accident in a lab. Somebody wasn't following lab procedures and had gotten some of the stuff on their glove and maybe wiped their mouth like that and touched it with their tongue, and they were like, oh, this is sweet. And so I've always said, don't be afraid to make mistakes, guys. A lot of times things that are used in science were discovered by mistake. So that was actually kind of an accident or a mistake where they discovered NutraSweet, or I think it was NutraSweet, or one of the substitutes for sweeteners. It was basically discovered by accident. We don't normally want to get into an area where we're changing or tasting things, especially if we're dealing with chemicals. Sometimes we mix things together and it actually produces heat, or it releases heat. So the temperature of something can increase or decrease. If a temperature of something is increasing, it's actually absorbing heat. If the temperature decreases, that means, so if there's something in here and the temperature decreases, that means the heat was released off into the atmosphere, into the air around it, and that decreases the temperature. So those are all examples of physical changes. And the reason I'm going over this again is because I did have some questions about how do I do this worksheet. A physical change could be a change in shape. I could take, if I was strong enough, I could take this piece of steel and bend it. I haven't changed it from anything else, but it's still a piece of metal, but I've changed its shape. I could take a lump of metal and I can heat it up and I can roll it out into a thinner piece of metal. This is a piece of plate metal. Is it still metal? Yes, but I've changed its shape, or I can change its size. This can be a small block, or it can be this big piece of metal. By the way, this is rusting too. Change in size. So think change in state, solid, liquid, gas, change in shape, change in size. Those are going to be the common ones as far as physical changes. Now the worksheet basically covers everything that we just talked about. And like I said, the two things, when we're mixing chemicals, the two things that we mix together are called the reactants. What we end up with is called our product. We're producing something new. Just like in math, you find a product. A product is the result of combining two numbers. It's the same thing where we're having a product. We're creating a new product. Other important thing to talk about is that one of the differences between chemical and physical changes. A chemical change generally is not reversible. A physical change is. If I take this water and I freeze it, it changes its state to solid. If I take it and let it sit out on the counter, it's going to change back to liquid. If I put it in a pan and boil it, it's going to change into a gas. I can change the state back and forth without, it's still going to be H2O. Chemical changes are permanent. They're not reversible, okay? So there is an assignment posted in Google Classroom for you to do. It is not, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's only 10 questions on it. It's not a big one. And as a bonus, I want you guys on your answer sheet to also do 2 things. I want you to write the word spaghetti. And I want you to give an example of your own example of a chemical change. So your own example of a chemical change. Okay? And so think about, make sure it's not a physical change. Matter of fact, you can do one of each if you want to. Those are bonus points. I'll write that down too, if I can spell. I've never been good at multitasking, talking and typing at the same time. Your own example of something you can think of that would be a physical change, or your own example of something that would be a chemical change. Anything that is not the same as something we've talked about, or, hey, Lucas is with us. We're about done, Lucas, but thank you for joining up. Make sure it's not one that's on the sheet. So your own example of a chemical change, your own example of a physical change, get it done. I will say there are still students who have not turned a single assignment in, and it's obviously not anybody that's joined us. And we've been trying to reach out to these students. I'm not sure what's going on with their lives. I'm concerned about them. Some of them you are good friends with. Yes, I know this, and I would appreciate it, and they should appreciate your friendship, that you guys are communicating with each other, and let them know that they need to be getting on, getting assignments and all that stuff. That being said, hopefully that answered the questions on the assignment and kind of reviewed what we talked about on Thursday. That's what I thought. I thought Don Williams was Lucas too. So make sure you guys are getting your assignments done, communicating with your classmates. If you have any questions, don't forget to email me. I put my email in the beginning of this change. It is my first name, my last name at Summit Academy. It doesn't bother me for you guys to email me. That's too bad that you haven't had contact with your friends, especially a couple of your best friends that I know. I'm going to be sending out emails again to reach out to some people, because how can you grade something when nothing's been turned in? I appreciate you guys that are working hard. I know this kind of stinks. You know, we've been told yesterday by the governor that we're not coming back. For me, I really, really miss you guys. I was lucky enough to see a couple students last week when I was in, and that made me really happy to see a couple people. And of course, I really wished I could give them big fat hugs, but we can't even do that, can we? So everybody stay safe, be careful, stay safe and stay healthy. And don't be afraid to email me if you have any questions. I especially miss your bad jokes, and I'm sure you miss my bad jokes. And it doesn't look like we're going to see each other, at least in school, for the rest of the year in a normal setting. But we always got next year. And I'm sure I'm running into some of you guys in the grocery store. Dimitri, I saw your dad in the grocery store. All right, you guys take care and have a good day, and we'll see you on Thursday. 8th grade at 10, 7th grade at 11, 6th grade at 12. All righty. Take care.